Okay, this is section 4.3, and so we're going to talk about what makes triangles congruent. Okay, so this is the first thing that should go into your portfolio when I give it back to you. Properties of congruent polygons. And so here are two triangles right here. Here's triangle ABC, and the corresponding triangle that goes with that is DEF. And what they've done is they've color-coded everything here. So angle A is a corresponding angle with angle D because they're the same measure. So if you have two different triangles, now what we're going to do, remember when we had two parallel lines and we cut two parallel lines with a transversal? And we had to figure out, okay, what are the corresponding, what are the exterior, alternate interior, consecutive interior? You remember that lesson? Well, now we've got two triangles, and we're going to use the same words again, particularly corresponding. So right here, this angle A is corresponding with angle D. What corresponds with angle B? Angle E. And C corresponds with F. So those are the corresponding angles. Corresponding sides, AB corresponds with what? DE. BC corresponds with EF. And so you can kind of see it a little more clearly when it's color-coded. So what we would say is we would say that these two triangles right here are congruent. What makes two triangles congruent? What has to be absolutely true to make two triangles congruent? They have to, would you say? Would you say? Have the same measures. So what kind of measures does a triangle have? It's got angles, so all the angles have to be congruent, and all the sides. That's exactly right. So two triangles are congruent if all of their corresponding angles are congruent and if all of their corresponding sides are congruent. That's what makes them congruent. Okay? This is a quadrilateral, 4 sides. Same thing again. In this polygon PQRS, angle P is 90 degrees, and that corresponds with angle W. And the thing that you need to know about the correspondence here is that when they give you a correspondence, it's actually letter for letter. So P corresponds with W, Q corresponds with X, R corresponds with Y, S corresponds with Z. And so there's the correspondence. So you have to match it letter for letter for letter for letter. Okay? Here's a triangle, RST, and here's a triangle, XYZ, represent the triangles of the space station support structure. If the two triangles are congruent, the first thing I want you to be able to do is to identify all pairs of congruent corresponding parts. And so all it means to identify is just to list them out. That's it. So R is congruent to X, S is congruent to Y, T is congruent to Z. That's all the angles. Segment RS is congruent to segment XY, ST congruent to YZ, RT congruent to XZ. That's it. That's all it means to identify. Is that something you think you can do? Pretty straightforward, right? So identifying, not a problem. Okay. Here I'm given that angle or triangle EFH is congruent to triangle GFH. I want to find the value of X. So here's the picture that I'm given. What relationship here has to be true? Give me an idea here. What has to be true about this triangle if I want to figure out what X is? Is 6x minus 12 equal to 180? Does that make sense logically? I don't think it does. No, not 180 degrees. What would make sense to say? Which, yes? Yes, that makes the most sense, right? Why does it have to equal to 90?
Because it's a linear pair with the angle right beside it.
You nailed it. It's a linear pair with FHG, and so if it's a linear pair and they both add up to 180, since that's 90, that has to be 90. So set 6x minus 12 equal to 90 is all we have to do. Solve for x, and we get x equals 17. What does, let's see if you can remember from the previous lesson, what does angle EFH have to equal? Don't just give me the number unless you know it, but how would I go about figuring out EFH? Just the guided practice tonight. Have a good night. How would I go figuring out EFH? I've got a nice handy-dandy little theorem from the previous section. Yes?
Like, I don't know. I think it's wrong.
Give it to me anyways. If it's wrong, we'll fix it.
Well, you already know H is like 90 degrees, right?
Correct. I know that FHE is 90 degrees.
Just kidding. Yeah, that would be totally wrong because, yeah.
What were you going to say?
Well, I don't know. I guess I thought like that just H would be. No, never mind. Wait, would F be like?
Just stop.
No.
I don't know. I mean, because I saw the little box for the H.
Okay.
So,
Would you agree with me?
triangle something.
Would you agree with me that FHE is 90 degrees?
Yeah.
Okay.
I agree with you.
Now, since FHE is 90 degrees, I know that this angle here, EFH, is complementary with angle FEH, this angle here.
Right.
And what does it mean to be complementary? Adds up to 90, right?
Right.
So all you have to do to figure out this angle right here is to subtract 21.6 from 90.
Okay.
And so when you take 90 minus 21.6, what do we get? We get 68.4, right? So this angle here has to equal 68.4 degrees.
Okay.
Does that make logical sense?
Yeah.
Okay. And that is always true 100%, and I can't remember your YouTube name.
Oh, we're on YouTube right now?
You're on YouTube right now.
That's so embarrassing. Oh my God.
Okay, never mind. All right, but
Facebook.
does that make logical sense? If you have a right triangle, then the other two angles in a right triangle have to add up to 90 degrees. They've got to be complementary. All right. Proving triangles congruent. I'm given that angle P and angle M are right angles. I know that R is the midpoint of PM. I know that PQ is congruent to MN, and I know that QR is congruent to NR. I want to prove that the two triangles are congruent in order for this to be true. What does it make? What do you need to show that two triangles are congruent? We need all of the what to be congruent? We need all the corresponding angles and all the corresponding sides. Now here's the nice thing. I know that PQ is already congruent with MN. That part's done. I know that QR is congruent with NR. That part's done. How can I show that PR is congruent with MR? How can I show that that's true? What'd you say? No, PR is a segment and MR is a segment. So I wouldn't use an angle theorem. Nope. Good try. There's something even more basic here. What am I given about R? What am I told about point R?
Midpoint of P1.
It's the midpoint of PM. So if R is the midpoint of PM, what has to logically follow from there?
PR and RM are the same way.
PR and MR or RM are congruent to each other, and the reason behind that would just be definition of midpoint. So now, do we have all of the corresponding sides congruent? Yeah, we do. What do we need now to show that the triangles are congruent? We've got all of the corresponding sides congruent now.
So you need the angle.
Now we need the angles, right. Now I already know that angle P is right angle and angle M is a right angle, so I already know that they're congruent. Why does angle QRP have to equal angle NRM? Why do they have to equal each other? Why does QRP have to equal NRM? Well, what kind of, from the picture, what kind of angles are they? We want to say they're congruent, but we can't just say it yet, but we know that they're what kind?
Linear?
Not a linear pair, no. They are acute,
Yes.
but that doesn't make them congruent. They are vertical angles. And from the vertical angles theorem, we know that vertical angles are congruent. So now I know that this angle here where the hand is congruent to this angle. And I know that this right angle is congruent to this one. So now why does this angle, where my hand is, have to be congruent to this angle? And this is where you're going to use the theorem from the previous lesson. This is the what angle? This is the third one. So this is, we're going to use the third angle theorem. So PQR, angle PQR is congruent to angle MNR by the third angle theorem. And now I have all the corresponding sides and I have all the corresponding angles. So the conclusion is the two triangles are congruent. So what I wanted to do with this proof is I just wanted to talk our way through it. Rather than go through the column proof, I think it's going to be more useful if I just talk our way through this kind of a proof right here. Okay? Okay. Draw this picture down. Draw this picture down. This one right here. And what we're going to do is we're going to do a talk through it proof. Okay? We're given from this picture that AD bisects BE, that BE, bisects AD, that segment AB is congruent to segment DE, and that angle A is congruent to angle D. I want to prove that triangle ABC is congruent to triangle DEC. The only way that you can show that two triangles are congruent, right now anyways, is to show that all their corresponding angles are the same and all their corresponding sides are the same. We're eventually going to get into something called side, angle, side, all those different congruence relationships, and we can use those later down the road. We don't have those yet, okay? So, how can I show, we're just going to do a talk through it proof, that's it. How can I show that AC is congruent to DC? How do I know that that's true? I do know it's true, but how do we know that it's true? No, AC is a segment, so I wouldn't use an angle postulate on a segment. Why does segment AC have to be congruent to segment DC? What bisects? Yes, there is a midpoint here. Where is it coming from? It's coming from the given, isn't it? Right here, AD bisects what? So that means that point C is the of AD, right. So if C is the midpoint, that means that AC is congruent to DC. Done with that one. How can I show that BC is congruent to EC? Why are they congruent? Why is segment BC congruent to EC? Same thing again, right here. BE bisects AD. So that means that C is the midpoint of segment BE, right? So BC has to be congruent to EC. So now, do we have all the corresponding sides the same? We do. Now we need what? Angles. So we know that angle A is congruent to angle D. What's the next angle to logically attack? C can't stand alone. That's a good, I know what you mean by C, but it can't stand alone because it branches out into two different angles.
ACB and DCE.
ACB and DCE, right. That's exactly right. So I know what you meant by that, but why do they have to be congruent now? Why does ACB have to be congruent to DCE? They're vertical angles. So from the vertical angles theorem, they're the same. What's the last angle to attack? B and E. Third angle theorem, right? It's the last one, right? Does that make sense?
Yes.
Now do we have all the corresponding angles the same? Yeah. So are the two triangles congruent? Mm-hmm. Yeah. Sure are.
Good job, Noah.
Is that his YouTube name?
It's his YouTube name.
It's actually good.
No, it's actually Noah Thomas.
Okay. I'll just say my
Okay.
Are we still recording?
We're still recording, yes.
Just want to read off my social security number.
We're gonna do number 11 in the guided practice together. So let's go ahead and finish this one right here.
Snapchat me, Kyle_10. YouTube.
Number 11.
I don't have one, but I'm gonna make one.
Let's do first a talk it through proof. Given that E is the midpoint of AC and BD, and that AB is congruent to CD, and that AB is parallel to CD, prove that the two triangles are congruent. Okay? So what we're going to do, let's tackle that midpoint idea first. If E is the midpoint of AC, then which two segments have to be the same? If E is the midpoint of AC, which two segments have to be the same? AE and EC or CE, those have to be congruent. And then, I think you already said it, what are the other ones? DE and BE, those have to be the same. Right, that's exactly right. Okay. Now look what we're trying to prove. We're trying to prove that triangle ABE, ABE, which is this one right here, the top triangle, is congruent to triangle CDE, this one right here. So I have this side matching this side, and this side matches this side. So now do I have all of the sides corresponding to each other? I do. What do we need next? The angles. So how do I know then? How do I know that angle AEB is congruent to angle CED? These are vertical angles. Yes, vertical angle theorem. Now, I have to use this parallel idea. I know that AB is parallel with CD. So this is going to take us back to alternate interior angles. So pretend right here that this is a line, AB. Extend that out, AB. And that CD is a line. What's the alternate interior angles that would be congruent? Can you list the letters off for one of the angles? What's one of the interior angles for the two parallel lines? ECD is definitely one of them. Yep. And that would be congruent to what? EAB, yes. So this angle here would be congruent to this one right here by the alternate interior angle theorem. What's the other pair?
EDC and EB.
You got it. EDC is congruent to
ABE.
ABE. That's the alternate interior angle theorem. And so now we have all the interior angles corresponding, angles congruent, so the two triangles have to be congruent to each other. All right, so let's just now fill in the proof. Number one, how do I know that AB is parallel to CD? Given. So the first part's just given. How do I know that ABE, angle ABE, is congruent to angle CDE? And that BAE is congruent to DCE?
Vertical.
Nope.
Odd.
Follow the letters. Here's ABE, so this angle here. And that's congruent to CDE, so this angle here.
It's given.
That's not given.
Under the parallel lines.
What's their classification? If AB is parallel to CD, then this angle here where my hand is congruent, this angle here where my hand is congruent to this angle here. What's their classification? Alternate interior angles. So the reason why we know this right here, line 2, is because of the alternate interior angle theorem. That's why we know this to be true. Okay? Because we know, we are given that this is parallel to this. How do I know that AB is congruent to CD? How do I know that this is congruent to this? That's given. So 3C is given. How do I know that E is the midpoint of AC and BD? What'd you say? That's given. So 4D is also given. Not everything. This one right here, if E is the midpoint, if this is the midpoint, and we already talked our way through it, which sides have to be congruent? Well, I know that AE is congruent to, what'd you say? EC, so that would go here. AE is congruent to EC. And what's the other pair? Yes, DE has to be congruent to EB. That would go here. So those are the two things that would go there. Okay? How do I know that AEB, where my hand is right here, how do I know that this angle is congruent to this angle? That's 6F, vertical angle theorem. And now that you have all of these congruent, we can now say that triangle ABE is congruent to CDE because all of the corresponding angles are congruent. This is what goes in 7G. All the corresponding angles are congruent and all the corresponding sides are congruent. And that's what makes them congruent. Okay? Does the talk through work? Does that help a little?
Yes.
Okay, thank you. All right. So tonight your homework's just going to be the guided practice. Like normal. Same song, second verse. Could be better, going to get worse. And that's it for today.